So here we have a fan that has three settings. You can have it on high, you can have it on low, or you can turn it off. And you have three of these fans. And so you're like, oh, I can create a different ambiance in my room. Maybe every night before I go to bed, I like the wind flowing in my room to feel a little bit different. So you set up these three fans in different parts of your room, and you could be like, I want it to be a stormy night, you set them all on high, or you want it calm, so you turn it all off. You'd have all of these different options. If we were using the fundamental counting principle, to do that, you would say, well, I have three decisions I need to make. I need to know how I'm going to set fan number one, then fan number two, and finally fan number three. Then for each of those decisions, we ask, how many choices do you have? Well, fan number one can be on, low, or high. That gives me three choices. Three choices for fan number two, and three choices for fan number three. So you can almost go a whole month and have a different experience before you go to bed for 27 days in a row. It's like wonderful, right? Now, if we wanted to list all 27 of those, we could just start listing ones, but the problem with just listing them without doing something systematically is then all of a sudden you'll be like, I've got 23 of them, but I can't figure out which ones I'm missing. So I'm going to show you a way of being systematic about this that we could list these quite easily. And the systematic way is something called a tree diagram. So for option number one, or decision number one, we draw three branches and list either off or low or high for those three branches. And this is why it's called a tree diagram, because we call each thing a branch, so it ends up making something like a tree. Then for fan number two, you have three options off of this one, three options off of this one, and three options off of this one. And finally, for fan number three, again, three options. I'm going to cheat. No, it's not fair. Three options, three options, three options, three options. And you can see why this is not necessarily the nicest strategy for counting them, because it gets very big very quickly. But if you had to list them, right, on the very calm night, that's all of these branch number 111. It's like, ooh. You're looking for, oh, look at this. Here's the humorous night. There we are. There we go. So this, if we wanted to, we could go through and list them all. Right? And keep going. This would be a systematic way. If you needed to list all 27 of them, this could do that. Right? So I want you to, well, first, before I give you the homework for this one, we're going to go and highlight the fundamental counting principle in our notes. And beside this, we can translate this . This is the This is the fundamental counting principle in easier to understand wording. We're going to make a space for each decision we need to make. How many decisions did we have to make for our fans? 3 decisions because we had 3 fans. Then we write the number of choices we have for each decision in each space and multiply them together. So we could have even done that for the heads and tails and the spinner. You had 2 choices for heads and tails, 2 choices for the spinner. We came up with 4 in total. So we can do this for a lot of questions. Now, I'm going to give you some time to try these first questions. And they are 3, 4, 6, 11, and 12.